Now, just a little bit of notation here. The number of multi-permutations of a multiset that has k different kinds or types of element and a certain number of each of them is n factorial for the total number, and then underneath j1 factorial times j2 factorial all multiplied times jk factorial. So compare that to the formula above for our specific example of Mississippi. The j1 is 4, j2 is 4, j3 would be 2, j4 would be 1, and all those numbers, j1 plus j2 plus all the way up to the last one, however many there are, have to sum together, have to add up to n, the top number. So sometimes people do write this a little bit like a regular combination by just putting the big number on top, n, and then just listing the smaller numbers with the space between them on the bottom, and without the fraction bar. You always put the fraction bar in at the same time you put the factorials in and multiply things together. So if you just write it the fast way, you skip the fraction bar. That means there is another way of writing 7 choose 3 on the next line down. You could write it as a multi-permutation, because it's 7 over multi-permute 3 and 4. Notice they both come out to the same thing, 7 factorial divided by 3 factorial times 4 factorial. And that comes from that same bijection we talked about up above. Combinations, oh no wait, sorry, this is a new bijection here. The one we mentioned up above, nope, sorry, it is. It's the same thing I was thinking of. So combinations are in bijection with 2-letter multi-permutations. That's what we mentioned earlier. So there has to be exactly 2 letters like A and B. Now, this last line is where it can, it's probably already somewhat confusing and needs to be, you need to try some problems. We'll do some examples on the board next. But the last line is where it can be extra confusing unless you read it through several times and look at examples. Multi-combinations, which, remember, those are like bookshelves or bookcases, plans for a bookcase without putting the books on yet, or they're multi-subsets of a multiset, do turn out to be in bijection with 2-letter multi-permutations. So all combinations can be put into the framework of 2-letter multi-permutations if you want to see that bijection. Because the multi-combinations are just written as a regular combination where you have to add the 2 numbers together, k plus m minus 1, choose k. And that can be written as a 2-letter multi-permutation with k plus m minus 1 on top, k and m minus 1 on the bottom.